Welcome to the Requirements Working Group meeting for August. Certainly glad to have you. But today we're going to look at this job-centric approach to validating your system design, brought to us by Henrik Mattfolk, who is a certified system engineering professional. He's based out of Michigan. He's got over 2 decades of dedicated experience in system engineering and product development. He has established himself as a leader in adopting the MBSE, model-based system engineering practices, within large organizations. He started his career in Sweden after earning a Bachelor of Science in Computer Engineering from Linköping University. His professional journey began at ABB, where he developed cutting-edge measurement systems. Then he joined Whirlpool, where he ascended through various engineering roles to become the principal engineer for MBSE. During his tenure, he became the global leader for system engineering adoption initiatives, spearheading system engineering training programs across the global organization. And recently, he's joined the medical technology domain as a process owner for requirements management at Stryker. With that, we'll hand it over to you, Henrik.
Thank you very much, Kevin. So before I get into the actual presentation, let me just say a few things to kind of set the stage a little bit here. So first of all, this talk will be a little bit different from what we normally talk about in this setting. So I'm not going to talk so much about requirements today, but we're going to talk more about needs and expectations from stakeholders. And also how we can do rapid assessments of preliminary solution concepts to those expectations. And this is really a kind of a natural place to start when we're trying to figure out the bigger question here. So are we designing the right system? You will also see throughout this presentation that we don't need to develop all the artifacts in between needs and design definitions before we can start to get a feel for how different solution concepts will actually perform. And that's important for our ability to complete a system validation, or at least some kind of preliminary system validation early in the conceptual phase before we have invested too much into a specific design. So the question here, is there a way for us to know if we are about to develop the right system? And that's what we're going to dive into today. So I don't need to explain the value of systems engineering to this audience, but let me just underline that a successful system must satisfy the needs of the customers, users, and other stakeholders. Therefore, it gets really important for us to understand how our users are thinking, how they are judging if our system is successful or not. And maybe even we're setting the bar a little bit low here. We're saying satisfy the needs. That feels like we're just kind of reaching the bar. But I think we should actually aim a little bit higher here. We really would like to delight our users and kind of a little bit exceed their expectations. So I think that's a good kind of aim here. So drilling a little bit deeper into the problem statement. So for any given solution concept, the question is, will we be winning in the marketplace? And let's say that we have developed requirements, we have realized the system, and we're verifying it to requirements, and everything is kind of blue skies. Is that sufficient to be sure that, yeah, we have a successful system? Actually, it's not. I got those requirements wrong, and we could have potentially developed still the wrong system. So we're coming back to this thing of we need to know how the stakeholders think, the metrics, or how they measure value and success. How can we visualize this? If you worked with marketing teams, you probably come across a concept called journey maps. And journey maps, they focus on, well, as the name kind of suggests, the journey that someone is going through that is involving the system. But what we're capturing here is kind of emotions and how we feel going through different phases. And that can be anything from a sad to a neutral to a happy phase. And of course, you need to do some research in order to figure this out. You need to interview and survey and those kind of things, and get that kind of consumer insight. Where we have sad phases, it's probably fairly easy to figure out what it is that they don't like. But in order to optimize systems to do better on this kind of feeling, it would be very helpful to know a little bit more about what is actually making up that rolled up feeling. Ideally, what we would like to know is this kind of level of delightedness that we see here. What kind of parameters is going into that equation that is going on within the stakeholder? That would definitely help us to improve, and we would know a little bit better what to optimize our systems to. And I think not only where we have sad phases here is there an opportunity for improvement, but also where we have neutral phases. The neutral phase is not a happy phase. So there's an opportunity there as well. If we knew a little bit more what we should optimize to, we could probably do a better job on getting this kind of journey and the emotions here closer to a happy phase. So think about that kind of neutral feeling. For example, starting a car 20 years ago, that involved a key. You turn it, you kind of listen when it's kind of cranking, and okay, now it starts, then you release it. You were not necessarily sad about that. But nowadays, you just push a button, the car takes care of everything, super easy, right? So that's what I'm saying. There's still opportunities here, even though we may not have kind of an aggravated customer. And we'd like to know what matters so we know what to optimize to. So the question is this something we only need to be concerned about for novel systems that are kind of new to the world and we don't have a lot of experience in? Are mature systems that have been around for a long time, are they efficient in meeting all kind of expectations from stakeholders? So there's not much work to do there. Let's look at a system here we're all familiar with, a gas pump. We can at least see two different designs of a gas pump. One is based on one nozzle, and you have buttons to press to select the fuel grade or the fuel type. The other one has several nozzles representing the fuel type and the fuel grade. So question is, which one is better here? And there's also a person here involved in this system, and they're doing some kind of job. They're, in this case, filling up gas in a car. And question is, how do they think? What is important when you do this job of filling gas in your car or diesel? So maybe one thing that is important is that you would like to minimize the probability of filling the wrong fuel. That's really important. And how about these two different designs? Is these systems doing a good job on this today? Well, what about design A? You grab the nozzle and then you have to push a button. You have to actively confirm that this is the fuel grade or fuel type that I want. And design B, there you just need to grab the nozzle and you can start filling. So is this happening successfully every time today? Actually, it's not. I at least found some data on the internet, if we believe that. But it's basically saying that in UK alone, it's estimated that 150,000 times a year, someone select the wrong fuel grade at the pump. Coming back to that journey, that's going to result in a pretty sad phase, right? So the answer here is that none of these two designs probably are great when it comes to this expectation. I haven't done my research, but I suspect that maybe design A is a little bit better because you're actively confirming. So again, there's improvement potential here for sure. What else do they think or care about when you're filling up gas? Well, we have the usual suspects here, minimize number of operations or minimize time. How are these two different design concepts delivering to that expectation? On design A, you remove the nozzle and then you push a button. You're basically two operations. Design B, you're removing the nozzle. That's actually easier. There's at least one operation less on design B. So design B is actually doing better on that particular expectation. We have a business here as well who's selling gas. How would they think about the system? What do they want? Maybe they would like to maximize sales. I'm maybe not the only one who thought about, so when you're standing there filling gas or about to fill gas, it seems like it's a little bit easier to reach to the more expensive fuel grade. the 93 octane instead of the 87. It's probably not a coincidence that that one is a little bit closer to you when you're actually filling gas. So you see how these kind of designs are optimized to cater to different expectations. But my point here is even mature systems are not necessarily doing perfect. You would think that today, if you go to get some spare parts, for example, to a shop based VIN number, they know exactly what kind of fuel grade or fuel your car run on. So maybe there's improvement potentials here as well. We could do better, but we need to know what to optimize to. When we talk about value, it's very important to recognize where value is generated. We're often laser focused on the system itself or the components, very fun to kind of look into that. But value is really delivered and created in the system context. You have people involved with the systems. They are performing some kind of job, in this case, making better. That's really where this kind of value is being created. And this context is really collaborative. You can at least take any legitimate user or someone who's performing the job, and you can come together, you can talk about the job, you can hear them out, what's important, and how they ideally would like to go about this job in order to have a kind of a positive experience. So very collaborative. It takes some time, of course, to dig into those things, but a lot of people can come together to look at the system context. Start to decompose this or focus more on the system itself. We get more into kind of emerging functions, the behavior, emerging properties, and we can continue down to decomposing the system, look at the components, how do they interact, what kind of component performance do we need. Now it gets a little bit more engineering, and it's maybe more difficult to involve your stakeholders on that. That's why I think it's so important to pay enough attention to the system context here, because that kind of sets the direction for what you're going to do when you work with the system and the components. We like boxes, so let's translate that into different kind of artifacts here. So this looks kind of like your left side of the V here. So we have needs, stakeholder expectations, we have operational concepts, and at the end of the day, we will validate our system to those artifacts. I'm going to consider here the operational concept as a response to needs and stakeholder expectations, not necessarily an input. One of the reasons why we like to do that is because we don't want to constrain the solution too much in the need space. Now I'm going to change kind of nomenclature a little bit here. So we're talking about needs and expectations. So this talk is drawing from the framework called Jobs to be Done. That framework is pretty large, has many different concepts, but picking some concepts out of that framework that is beneficial for us when we work with validating our systems. Two important concepts here that will help us when we go about needs and expectations elicitation, and also to help us to not drill too deep in that domain to kind of lock in solutions. They refer to artifacts here referred to as jobs and outcomes. There are different jobs. We're going to talk here today about functional jobs. Think of functional jobs as something that is very closely related to the basic purpose of your system. We don't want to get into different tasks you do at the lower level with the system. It should be a high-level job that is the reason for your system to exist. And then there's another artifact here called outcomes. The outcomes are going to clarify how we measure success while we are performing the job. So that can be during the execution of the job, and of course, the final outcome of performing the job. And you see how we now start to get a little bit deeper into something that's more measurable, not just can you do that or no. No, we want to know something that is a little bit more measurable and how we're doing on those metrics. That would be important for us to be able to assess a future solution. We're also going to define operational concepts, and I'm saying concepts because these jobs, they should be open enough such that you can tweak a little bit the operational concepts to come up with different solutions, different variants. of course linked to different system designs. So you have a little bit of wiggle room in the solution space to deliver the job. So let's look at an example here, and let's continue on this job of mixing batter. This functional job we can transform into a need statement. As a family member, I need to mix batter so that I can make pancakes. And that's a functional thing. I just want to do that job. And of course, the system needs to offer you an opportunity to do that job. And then we have the outcomes. So now we need to figure out, okay, so the person performing this job, how do they measure value? That can be kind of consciously or unconsciously. We need to apply some elicitation techniques here to discover how they measure things and what they measure. Something that is kind of obvious when mixing batter is the kind of the physical effort. And when we think about outcomes, we want to think about something that we are minimizing or maximizing. So that's a good elicitation technique to help you define that right. And it should be, of course, from the user's perspective. So you would probably like to minimize physical effort while you're mixing this batter. It's good if it's not like a workout. It's going to be more appreciated if you don't need to put so much physical effort into it. So that will result in a different need statement that is in this kind of outcomes bucket. As a family member, I want to minimize physical effort or mixing batter. I want you to think about these two things. They are kind of, I would say, the corresponding concepts in the system context, as we have, for example, functional requirements and functional performance requirements in the solution domain. The job is kind of the function, and the outcomes becomes more kind of the performance metrics, similar to performance requirements in the solution domain, which makes sense. You want to be enabled to do something, then the question is how well do you perceive that you're able to do that? So that becomes your outcomes in the system context. So let's build this list of outcomes. So the job stays the same, probably related to every job. There will be a handful of outcomes. And we already talked about minimize physical effort to mix. Maybe you want to maximize the smoothness of the batter. Maybe you want to minimize the time it takes to mix. So that's one of the usual suspects, minimize time. And also you would like to minimize the time spent on cleanup. So now we start to have a couple of outcomes defined. And these start to sound kind of similar to another concept that we're well familiar with. Some of these may be your MOEs. They are metrics that describe how well you're reaching your operational target or the job. So now we have a start here. We have a job, we have a couple of outcomes. Now we can start to think about different design concepts, ideally with associated operational concept definitions as well. So we can apply here concept A and concept B. And remember back to the journey map. So we want to start to build this function, understand the function that kind of lives within the users, how they use different metrics to produce this delightedness or some kind of value metric. So now at least we have a start here to the input parameters to this function. We may not have a fully understood function at this point, but we start to have an idea about the metrics that are going into that function. So that's a good start. So with these metrics, what you can now fairly easily do, even without creating any more additional knowledge about these, how they, for example, the importance between them. So take these two concepts, concept A and B, and towards any given outcome metric, it's fairly easy to determine whether concept A or concept B is doing better on that particular metric. So minimize physical effort to mix, pretty obvious that it's the electrical hand mixer that's doing better. Maximize smoothness of the batter is going to be more smooth, of course, with concept A. Minimize the time it takes to mix. It's going to be faster with concept A, at least for that kind of job. And minimize time spent on cleanup. That's probably where the concept A is going to do worse. It's going to be a little bit faster, kind of grabbing that beer and the whisk and also just put that in a dishwasher. So that is probably doing better on that particular metric. This is kind of a fairly easily digestible view of comparing different design concepts. Imagine what you could do with this if you are in the business of manufacturing electric hand mixers and your competitor is performing like we see here, and your new product. We looked at these different outcomes. We compared it to how well the competitor performs towards that. And it should be fairly easy to understand if we're neutral or if we're doing better or worse. As long as we can see kind of a positive picture here that we are doing better than the competitor we're trying to beat, that should give you some confidence, and you should be able to sleep a little bit better, at least looking at that kind of comparison. And we know that this is roughly how the humans think that use this system, and we are doing pretty good on those. Of course, the question is, this is not necessarily just an exercise in writing. So the question is, how do we discover these outcomes? I think if you're in the business of selling a product, manufacture, develop a product, and been doing that for a long time, this is probably tacit knowledge. Many of these things are probably already known, maybe not kind of written down in this form. If you need to learn a little bit more, of course, interviews, kind of walk the job with users, understand what they actually value, and so on. To get a little bit more serious about understanding which outcomes that are underserved and how important one is versus others. Maybe you have a gut feeling there too that could be sufficient. If it's not, that's probably where you need to start a little bit bigger campaign of creating surveys and doing interviews and so on. The point here is that the foundation to be able to do this is to define your jobs and your outcomes. And then you can propose solution concepts. And we're also going to see it as operational concepts goes a little bit hand in hand with solution concepts. Operational concept can change depending on solution concepts. But we take those two artifacts and assess it to the jobs and the outcomes that we have defined. And just to illustrate, the operational concept goes hand in hand with the solution concept. So the job in this case is to correct some kind of visual impairment. You can use glasses or you can use contact lenses. But you see how the operational concept will change a little bit depending on these two concepts. So they go a little bit hand in hand here, producing solution concepts and we're assessing them towards outcomes. So to make this comparison a little bit more professional than sad and happy faces, you can come a long way actually with just a Pew matrix. You put your outcomes on the rows here in the Pew matrix. You can add cost if you want as well. And then you put your solution concepts on the columns. You're always using one as a datum here when you do a Pew matrix, and you're comparing the other concepts to the datum. Even without knowing exactly the importance of how these things relate to each other, so you can see things like, for example, when one concept is completely dominated by another, that would be very obvious in this, and we don't need to construct a fancy equation to do that. We can also spot things like when a proposed new design maybe benefits some metrics, but you would suffer on other metrics, and that was maybe not exactly what you intended. So that's also kind of easy to see in these kind of matrices. Or if we're planning to launch a design change to our product, and when we assess or look at the value metrics or the outcomes, we're not seeing that we're moving the needle on any of them. That's another situation that you can easily spot if you do this kind of exercise. The gold standard here is to do trade space analysis. And to do that, you need to extract this value function. So you need to understand the importance of these different outcomes relative to each other. Otherwise, you're not going to be able to do a kind of rolled up value. The Pareto frontier is what we like to select concept close to. It's not necessarily that we need to pick something that is close to utopia. It can be a range of products that spread on the cost scale. So on those two examples that we looked at now, the electric hand mixer and the whisk, Those would probably place something like this. I haven't constructed the function perfectly, but I can still map it. I know that there is a cost difference, and I know that at least for this particular job, the electric hand mixer is going to produce more value. So that's going to be higher. Since these two products are probably along the Pareto front, different cost ranges, they may, of course, make sense, both of them. We can probably sell both and may not necessarily compete with each other. So let me just reflect on a few things, and then I will go through a little bit more complete example. You probably start to get an idea about this already, but I just want to underline that these outcome metrics that we are talking about, that the humans or the users of the system are using when they assess your system, they are slightly different compared to the metrics that you can measure on your system. And let's just consider this job here that most of you do probably, backing out of the garage. So what's important here? As a user, think about what's happening when you're backing out of the garage. You get into the car, you start, you put in reverse, and then you want to see what's behind you in the backup camera. Sometimes that backup camera is not ready when you want it to be. So you have to sit there and wait for the backup camera. And that is one thing that is important to the user, and that's going to be an important metric. You don't want to wait for the system. That's kind of a usual suspect as well. You don't want to wait for the system when you're about to do something. So the metric that the user is using in this case is that you want to minimize the time you need to wait for the system. As a technical requirement on the car itself, we're going to talk about some time that is okay to spend kind of preparing for showing that video, but that's going to be like a time constraint on that function. So it's a slightly different metric. And we may not need to go to 0 on that time, because there's stuff happening in the system context when you're backing out. So it probably takes you a number of seconds at least before you even care about that backup video. So two different metrics. Also touching a little bit on systems thinking here, I like this heuristic of there is no way to know why a system was designed in a certain way by looking inside the boundary of the system. So we look at a ship, for example. Why is that ship designed that way? It's designed in that way, considering the oceans it's going to be on, the cargo is going to transport. We look inside the kitchen. Let's take that microwave. Why does it have a side swing door? Why not a drop-down door? It would be fairly difficult to get the food in there if it had a drop-down door. So that's going to hurt your metric of you don't want to be too agile or be at a certain length to use the system. The mobile phone has a certain set of functions. It's because the users would like to do certain things with the phone. Why is it a certain size? Because you would like to carry it in your pocket. So it's very difficult to explain a system just looking inside the boundary of the system. Also reflecting a little bit on different life cycle stages here. These jobs that we're talking about, they can be different depending on the life cycle state. Maybe if you look at it from a manufacturing perspective, their job is different compared to the people that are involved in transporting or selling or servicing or disposing your system. So you may have to be a little bit inclusive here and look at different jobs and how do they think when it comes to the outcomes. As systems engineers, we already think holistically on the life cycle, and it's also important here. We should not just please the customer in the operational phase. Of course, that is very, very important, but the system needs to be successful in the other phases as well. So let me get into the last example here. The job we're going to talk about here is to call someone. And that job we can then transform into a functional need statement. As an individual, I want to make a call so I can verbally communicate with another person. Going back to these outcomes, in the job of calling someone, what could be important things that really matters when you're doing that job? Again, we have the usual suspects here. Minimize number of operations. You want to minimize the time it takes. And you want to minimize the risk of dialing the wrong number. That's a kind of an embarrassing thing. That produces a little bit of a sad face again if you think about that journey map. And it's kind of fairly easy to reason on those things, I think, in the system context. It would be a little bit more difficult to articulate that in a system requirement. Probably it's going to more show up as system functions that can be there to cater to that expectation. But it's not going to be that requirement worded like that. I'm going to look historically here on different designs of systems that support you in the job of calling someone. So we're going to go back here in history to the rotary phone. Some of you are so young, so you haven't even used one of those. And then we have the push button phone and a mobile phone. So 3 different solution concepts. In order to help us here to assess these solution concepts towards the outcomes, we want to work a little bit with the operational concept to figure out what's the number of operations, how long time would it take. We need to work a little bit with the operational concept before we can take these concepts and really assess them towards the outcomes. Okay. And how do we do that? I think a very simple way of defining an operational concept, which can maybe be scary to some people because it sounds complicated, and how would you even go about creating an operational concept? I don't think it needs to be that complicated, to be honest. It's basically about storytelling in the system context. And again, that's very collaborative. We can involve a lot of people to have an opinion about that and help to develop the operational concept. It will also reveal if we know how our system will be used or should be used. Sometimes you're like, yeah, I know. And then say, okay, write it down. And then you go like, oh, wait, you think a little bit extra. And it's like, oh, wait, maybe we don't know that. It will be beneficial also because it aligns the team on how the system should be used or will be used. That's always good to be aligned on. Of course, we can validate the realized system or the proposed design to the operational concept, the concept we developed. Can that actually deliver to the way we want to go about using the system? We can also think about not just kind of sunny day scenarios. We can think about rainy day scenarios when we think about this story that is playing out in the system context. And maybe some design concepts will do great on sunny day scenarios, but they will be terrible on rainy day scenarios. So not necessarily just a typical use scenario. You can think about different stories here. I think it has a benefit when it comes to reducing risk after the fact as well. So when you modify the system, you can look at some behavior and say, hey, why is that behavior there? I don't think we need that. We can remove that. If you have a good operational concept that tells the story of how someone is using the system, that could probably be a good rationale to why that system behavior is there. Also, storytelling in the system context is a good artifact to have that you can extract use cases from. So there might be 5-10 use cases happening with your system along that journey, and it will be easy to extract. And use case diagrams are not time sequenced. They just happen at some point, but you don't know necessarily when. Storytelling in the system context can really explain how things can happen over time. Now, developing the operational concept for these 3 different systems, and I'm not going to read through this, but you can almost see here by the length of the text description of how someone would go about calling someone with these 3 different system concepts that it looks more complicated with a rotary phone, a little bit simpler with a push button one, and a lot simpler with a mobile phone, at least if you have the person in your phone book. It doesn't necessarily need to be more complicated than that. And that's why I think we shouldn't shy away from storytelling and defining those operational concepts. Now you can use that when you make this kind of assessment. And again, we have the value metrics here. They minimize operation, minimize the time, and risk of dialing the wrong number. So the rotary phone is used as datum here. The push button phone is, of course, doing better on minimizing the operations and the time it takes to dial. Mobile phone is doing even better. And then minimizing the risk of dialing the wrong number. I think maybe the push button phone has some advantage there as well, but definitely the mobile phone is doing a lot better on that one, since you don't need to remember the phone number, you have it stored in the phone. So that happens sometimes today as well, so it's not perfect, but probably a lot less than it used to. Cost is of course higher for a mobile phone, and that need to be considered. If we would take now this and plot it in a trade space fashion, then we would see that if we assume that the push button phone and the rotary phone cost the same, there is basically no benefit for the rotary phone. That's probably why we see that completely die. The push button phone, though, still lives in some places. You can see them in offices, stores. It's significantly cheaper than a mobile phone. You can see here it costs more, but also delivers more value. But that may mean that those two products maybe can exist in parallel. They could both have a market. That's basically what I wanted to talk to you guys about. And just as a summary here, the message that I'm trying to convey here is work with jobs and outcomes, define them early as possible in your conceptual stage. And then when you work with system design concepts, now you're going to assess those and optimize them to your outcomes. They become your North Star here. Otherwise, it's like you propose a design and the question is why? Why is that the right design? The answer to that question is because my design is performing really well towards the outcomes. And of course, we shouldn't do this late in the project. We want to do it in the conceptual stage while we have not invested too much in developing a specific design. All right, I'm going to stop there, see if there's any questions.
Henrik, this is Lou. One thing I really like is this really illustrates a message that the requirement working group in our products is trying to get across is the importance of understanding the problem, the needs, the lifecycle concepts before you define a set of requirements. And also there's stakeholders other than the users and customers across the lifecycle. And so each one may have a different job based on their role and they all have their needs. So all that upfront analysis, I think, is key to project success. So I really thank you for this perspective that you've given in your presentation.
Thanks, Lou. Thank you.
This is David Ware. I do have a question. I'm a fairly new systems engineer. I've been in quality many years. And we are, at my employer, currently looking at designing a new industrial control system for a new factory. And we have begun the elicitation process to develop requirements from, and we're following the IEEE 29148 standard, which is an iterative process that goes back to the people you're eliciting from to get validation. Is there a source, a resource? Is there some area where you would recommend I turn to for additional detail about this process? I mean, this presentation was right squarely at what I'm trying to come up to speed on, but I feel the need to dive in a little bit further. Would you recommend a particular volume or other resource?
I would recommend that you go to YouTube and search for jobs to be done. You will get a lot of results there, but I particularly like many of the webinars that Tony Woolwick delivered. He also has a book on the topic, What Customers Want, I think is the name. That would be a good resource as well. I can really recommend to read that book. I'm not getting any profit, but I enjoyed that book.
Thank you. And what was that last name again?
Tony Woolwick.
Woolwick. Okay. Thank you.
Mm-hmm.
This is Sarah Vasquez, and everywhere I've worked, I've been in systems engineering for about 17 years. I feel like I've never really gotten to experience this needs and outcomes phase, but I like it very much. And the reason I've never experienced it is every customer stakeholder I've worked with already comes to you with a really detailed set of requirements, 20, 30,000 requirements. And I feel we jump into the details so quickly, you don't really have a chance to understand what's needed and to do your own systems engineering development based on the needs. I'm just curious what you think about that. What's your experience been?
Yeah, I don't think that is uncommon, and that is also my experience. I think oftentimes when you have a marketing function or some kind of consumer design function and you have a developing organization, it's probably very common that you just get kind of, okay, do this. Here's a design of user interface. Just do this. Here's what the product need to look like. Just do that. I think we're missing out a little bit. Systems engineering is a team sport. I don't think we should operate as you throw stuff over the fence. I think this intersection between the solution domain and the problem domain should be collaborative. And I think maybe as a systems engineer, you cannot lead all those activities, but I think we should be part of them. maybe the view I am giving you today is a little bit from an engineering perspective. What's matter to us, what we would like to know. Maybe we can help to come up with ideas about doing things better if you just told us what we need to optimize it to and not just say this is exactly what we want. But I think this is a very common thing between a marketing, sales, consumer design organization and the developing organization. So what would be a recommendation? A recommendation would be to tag team, reach out and say, hey, it would be nice to be part of this. I documented these things. Is this correctly understood? I mean, you can also take the lead on these things and go to marketing teams and ask them, is this correctly understood? Do I understand that this is what we're trying to optimize to? So it can be your kind of view of the world if you're not getting it from your upstream stakeholders.
That's why I like, Henrik, the title of your presentation is all about validation against the needs. And if a supplier is given only the requirements without the needs, how does the supplier address any validation activities? All they can do is address the verification. We recognize that as a problem. So if you look at the guidance in the new System Engineering Handbook under system requirements, you'll see that we provide some guidance in this area on how to address the customer requirements.
Do you have any tips for people who just start using it or would like to start using it that would prevent them to be trapped in nasty surprises? What's your experience? Do you have any tips for people who just want to start with the concept?
Just getting started on kind of methodology that we talked about today. If I look to myself, I basically started to educate myself on the framework. So I think that's a good start. If you prefer more like webinar style things, then go to YouTube. There's a lot of good material available there. If you like to get a little bit deeper, I suggest that you find a book on the subject, Jobs to be Done. Today is an introduction to this, but you maybe need to dig a little bit deeper and see if there's other parts of this framework that you can use as well. And then just practice. You need reps. I use this fairly frequent, and if I'm facing a new kind of system modification, I can go through this pretty fast. But you're not going to maybe go so fast the first couple of times. So you need some reps. But I think, again, the recommendation would be try to get a good theoretical base and then just do reps. Not sure if there's a support community out there. I have not necessarily come across that, but I would be happy to help anyone who would like to know a little bit more about this and get a little bit of help how to get started.
Looks like Carlo has a hand raised.
From what I understood, it's important to keep into account both the aspects of operational concept, which has been widely developed during this, exemplified during your wonderful presentation. At the same time, I think it's important to keep into account the concept of operations, the company enterprise and its mission and its evolution and so on.
Right. Yeah, of course, the concept of operation is going to give you boundaries. You cannot stray away too much in your operational concept. Maybe thinking about that a little bit more granular level, exactly how you go about certain use cases. And to be honest, I haven't personally have not been very much involved in concept of operations and planning kind of at an enterprise level, how to operate when it comes to different life cycle phases. How do we take care of service and those kind of things? But that will put some constraint, of course, on how much you can play with the operational concept. But the idea is that there should be some wiggle room. If you're given an operational concept, this is exactly what needs to be done, and this is exactly how it needs to work in the system context, then maybe you don't have much space for innovation. So sometimes maybe it's really locked down and then there's not much to do. So maybe this approach won't make a ton of sense if everything is very, very locked down by the acquirer. But if there is some wiggle room, then I think they start to make some sense. I may not be the best person to kind of advise on concept of operations and those kind of things.
Thank you.
I would just like to make a comment. I'm glad that you brought up the day in the life and bringing in other people, the so-called experts, for example, the end users and the requirements generation. Too often the engineers forget those people and just kind of have our own ideas of how a system should work, but without bringing in my case, the maintainers or the aviators. It's a very difficult task to get the requirements really what they need to be.
Thanks for bringing that up. I think that happens so often. I mean, as engineers designing products, you have a little bit of a shortcut into modifying the design, and maybe the improvements of the design are not necessarily properly vetted with the actual users, stakeholders. I think that's very, very common. Sometimes it's the right thing to do, and maybe sometimes it's not the right thing to do.
All right, I think that pretty much wraps us up for today.
Mhm.
Thank you, Henrik. Very good presentation and good attendance.
Thank you very much.
Thank you.